Hello everyone, we will talk about correlations in this lecture video. What is correlation? It's a relationship between two quantitative variables. We really want to say, how is A related to B? When we have the data, we want to test the relationship between two variables. And remember the different level of measurements we studied earlier. We need to have at least ordinal level or higher level of measurement, which will be interval or ratio, to do correlation. In other words, we cannot do correlation with nominal variables. There are two types of correlation, of course. Positive correlation, individuals who score higher on X tend to score higher on Y, or negative correlation, individuals who score higher on X tend to score lower on Y. And if you have completed the bonus activity for this module, you should have seen this figure already. When you look at a figure like this, don't jump into the bubbles or the details. Take a look at the variable names first. So the x-axis variable represented income level per person in each country. So all the way from $500 to $128,000 average income. And on the y-axis, this is life expectancy from 20 years to all the way to 80 years. So you need to understand the basic relationship between these two variables. So what does it mean if there's a country in this area, like in the video? It means this country has people with low income on average and low life expectancy. That means this person is, citizens in this country are generally poor and sick. And if you go all the way to the top, that means if you look at those countries, that means people in those countries are rich and healthy. They live longer life. So you understand the relationship between those two variables. Then you look at the figure. There is a clear trend here. So countries with low income tend to have lower life expectancy in general compared to the country with higher average income. So you see, this is a very clear positive relationship, which we call positive correlation. And of course, this figure provide more information than just those two variables. A different color represent different continent. The size of the bubble represent the size of the population for each country. But you don't have to look at all that. A simple figure like this, we just want to understand the relationship between x-axis and the y-axis. And there is a relationship between income and the life expectancy very clearly showing in this figure. And you always want to find the variables in the data set that really make sense to put them together in one figure. If I change income to, let's say, how many plastic bags you use per month may not be related to life expectancy directly. So you want to have some theory, you want to have some assumptions before you start. Why are you putting two variables on the same figure to compare their relationship? Look at this one, it's a simpler one. Let's say the x-axis represent age and the y-axis represent the number of house you have lived in. Of course, when you're very young, you probably only live in one house. It's very likely when you get older, you will move around more. You have your family, you have your own family other than your parents. You probably moved for school, for job. So there is a trend here. It's a positive relationship. When the value on X grows, the value on Y tend to grow as well. Of course, there are people who are different. Let's say this person lived this person. Let's look at this person here. This person is very old because it's on the far right end on the x-axis. But this person only lived in few houses compared to all the other people who are younger than he is or she is. So this is what we call outlier. And this person is very young because his age score is very low, but he lived in many places, in many different houses already. So those are what we call outliers. They don't really affect the whole relationship. You look at the overall trend, not the specific cases. So this is what we call a scatter plot. Each dot should represent a data point that you measured both x and y. This is a positive correlation. Although you do see some outliers in this figure, relatively speaking, this figure is still very perfect already theoretically. So you will have messier graphs when you analyze real data, but still remember you're only looking at the overall trend. And of course, when the figure gets messier, when the data points are everywhere, it will be even harder for you to observe the relationship. For scientific research, we need to have a more quantified way to measure correlation. This is why we propose Pearson's R. It will tell us the strength and the direction of a relationship. This is inferential statistics that we will calculate a lot for quantitative research, but remember, you don't need to calculate on your own. The computer will give you the number. You just need to know which button to click, and that's what you will learn in this module. So right now, let's just understand this conceptually. Remember, Pearson's R tell you the strength, how strong the relationship is, and the direction. It can be either positive or negative. Significance tells us whether statistically the relationship is different from zero, and we usually assume that's our null hypothesis that correlation is zero. Excel will give you a significance value, which is a p-value, and if the p-value is smaller than 0.05, we say there is a relationship between the variables. So it is a significant result when the p-value is smaller than 0.05. And if you remember from last module, we talk about what significance really means. We're just checking whether it's possible the relationship we're observing is just due to chance, not strength. We want to reduce the probability of making a mistake, making a type 1 error. That's why we want a small p-value. How small would be enough? Smaller than 0.05. And next, you want to look at direction and strength. So when you're looking at the scatter plot, this means a positive relationship because when people's value on x goes up, the value on y correspondingly also goes up. So there is a positive trend. And this will be a negative trend. So when the value on x goes up, the value on y tends to go down. So that's a negative relationship. And it's represented by a positive or negative sign in Pearson's R. You will see some example later. Strength, Pearson's R is essentially a value. It can be positive or negative, but the absolute value is always between 0 and 1. 1 means perfectly correlated, and positive 1 means perfectly positively correlated, and negative 1 means perfectly negatively correlated. So it's always somewhere in between. 0 means there's just no relationship. If you got a value smaller than 0.3, we usually consider it's a pretty weak relationship. If it's between 0.3 to 0.5, we'll just call it a weak relationship. If it's between 0.5 to 0.7, we'll call it moderate. And over 0.7, we call it strong. There will be different kinds of rules of thumb you will come across, but in general, less than 0.3, very weak. Around 0.7 or around 0.7 or larger than 0.7, we consider it as a strong relationship. Somewhere in between, we just call it a weak or moderate. So if you see this type of result in the quantitative research paper or quantitative research report, is saying that the data suggests that individuals who use more entertainment media use more social media as well. So you see, the more entertainment media, that's the X variable, the more, and then use more social media, that's the Y variable, which means when the value on X variable goes up, the value on Y variable will go up as well. So this is a positive relationship. That's why you don't see a negative sign here. It's 0.32, so it's kind of a weak relationship. But the p-value is smaller than 0.05, which means it is significant. And this is a perfect example how you report a result. You will use Excel to get this R value and this P value, and then you will write it up like this. You need to write your X variable, the Y variable, and describe the relationship. When X goes up, the more of X, will it end up with more Y or less Y? If it's more and more, that means it's a positive relationship. If it's more and less, then it's somewhere a negative relationship. And the P value tells you whether it's significant or not. So let's go a little bit backwards. Now you're looking at a correlation. How would you propose or state this as a hypothesis? What I would say is I would hypothesize that people use more entertainment media, would use more social media. That would be my assumption to begin with. So you see, with a hypothesis, you predict or you assume one direction to be true. That's what we call directional hypothesis. If we're talking about non-directional, then we're saying something will be different. So you don't know which one is larger. You're comparing difference instead of relationship. With correlation, you want to use the word more or less to describe how it goes, whether it's positive relationship or negative relationship. But remember, come back to this example when you do your own Excel practice questions to report your own result. Now, correlation can be really useful. When I tell you some things are related, it usually suggests you can do something about it. Let's say if the time you spend to study is related to your exam score, and I will predict, my hypothesis would be, the more time you spend on studying for this class, the better score you will get on your exams. So that's a positive relationship. I assume it's strong, but is that causation? Does that mean the time you spend really cause the result, as in this case, a better exam score? Probably yes, but there are a lot of times correlation does not mean causation. So I found a really interesting video to show you how ice cream can kill. Please watch that video to understand the difference between correlation and causation, because the way to examine causation is not through correlational studies. If you remember, we talked about this in the descriptive statistics and also the introduction for quantitative research. We have descriptive studies, correlational studies, quasi-experimental studies, and experimental studies. We are not covering quasi-experimental or experimental studies in this class. So you don't really have the tools to test causation at all. With survey research, with correlational studies, with correlational inferential statistics, you can only tell correlation, not causation. And I hope this video will make it really clear. Please watch that, and I will talk to you later.